Hi there. You are watching this video because you probably are thinking like, I really would like to hear what you have to say about the reasons for seasons. And so I'm going to try to explain my reasons for seasons here. Seasons happen as you get farther from the equator. Meaning if you're at the equator, typically you don't have much in the way of seasons, but the farther north and south we get of the equator, we find seasons are more pronounced. Seasons are caused by changing insolation. And this word insolation, that word insolation right here, means we're talking about the total amount of radiation that we receive from the sun. And that means at different spots on the earth, they receive different amounts of insolation over the course of the year. And this is caused by the length of day. That is different all the time, and the altitude of the sun. Those two factors, because they change, causes the insolation to change. Okay? So some things that you need to understand here. Number one, the tilt of our Earth. Right now it's 23.5 degrees. This is constant. As we revolve around the sun, our tilt keeps us pointed in the same spot in the sky. How do we know that? Well, because of Polaris. Polaris doesn't seem to move in our sky. And so we know that our tilt is continually pointed in that direction. Some people think that the Earth tilts one way and then it tilts the other way, and that's just not true. We are tilted in one direction. And so let me start over here. If you think of this flashlight, if I'm shining this flashlight down in this case right here, so it's shining directly on the surface, there's no shadow being cast. This is what I would call direct energy or direct radiation. And as that angle of this flashlight changes from here to here, the angle that it's shining on the surface here begins to change, and what will happen is that this stick will cast a longer shadow, and the energy from that light beam is spread over a larger area. So this is what we would call an indirect, and this is typically what we see in the sun during the winter, and this is what we see from the sun in the summer, a more direct angle. So that the sun would be higher in the sky. This angle that you see here would be the angle of the sun. Now we're not talking about a flat surface, we're talking about a curved surface. The sun is not moving. And so here the flashlights are all at the same angle. But again, as we get farther and farther from the equator, the angle that the sun shines at us is going to change. And so we can get more indirect radiation at some points as we get farther from the equator. So latitude is what determines how much sunlight we receive. And again, because our axis is tilted, if we have this flashlight at the same latitude, and we've got this in the two diagrams here, the northern hemisphere of the Earth, in this case here, is tilted away from the sun, and so they're getting an indirect solar radiation. This would be a winter view for the northern hemisphere, whereas over here what we're looking at is a summer view where the axis is tilted towards the sun, so we're getting more direct solar radiation. So what does that cause to happen for the sun in our sky? Well, we see these paths that in December the sun is following this path. It's a low sun angle, and it's not in the sky very long. So we have a shorter day, and the sun's direct or indirect radiation doesn't provide much in the way of warming. Up here you have a much longer path, so the sun is going to be in the sky for a longer period of time, and it's going to be higher in the sky, which gives us more direct energy. So what I've got written down here, the sun provides more direct energy when it's higher in the sky, and the length of day also increases. Those two factors, a longer day and a higher sun angle, gives us more warming and creates a summer season. So, here's my question to you. What are the reasons for seasons? Hopefully, you're going to tell me something about the length of our day. You're going to talk about the angle of the sun. These two factors cause changes in insolation. And the final piece of this happens in a periodic cycle because of something called revolution. The Earth revolves around the sun in a periodic cycle. Got it? I hope. Thank you.